Hello everyone and welcome to the course of data visualization. This video is about why we need data visualization or how did you get here. Is that you have some problems for growing up your business, so you have problems with telling a story about your data or describing your data or getting some features from your data. In all of the questions, the data visualization is making an answer. So how it works: data visualization is part of the product selling. So let's say we are some managers, top managers of firms that are great businesses, and we are selling, for example, a product of cola. So how the name Coca-Cola get to the way up? Because the product, what sells the product is the story of the given product. Now, what's the story about tells the visualization part of it. We need to determine our audience firstly. After having targeted audience, we need to make a story for the people. We need firstly to know our audience, to know our data features and characteristics, to know what to tell the people. We need to know our sales skills. We need to know our skills of our employees. We need to know our product advantages. We need to know how the story will end up, let's say. Uh, why we need data visualization, as I mentioned, it helps us analyze the data quickly and efficiently. It's providing an easy way of understanding. So it's better when you see an image of your data, when you see counts, when you see plots, when you see distributions, etc., rather than of just telling the people how your data looks, uh, just making abstract images of it. So mainly when we have data, we have a house, chaotic information, bunch of information that come along. And the visualization is the key, is the secret key of making your data readable. It makes connections between the performances, between the features, recognize trends. Otherwise, it can determine risk. Otherwise, as I said, it can determine the risk of your company. Then you can then target or you can make your future steps for avoiding it. In that way, it can help in the performances of the given business. So now, as data visualization is, let's say, separating in two parts: exploration. The exploration part of the visualization is to help us as programmers or as managers to understand the data, to understand what the data is telling us, to, let's say, read the story, to take into the gaps of the story, to read under the lines. In the explanation part, then we rewrite the story. We make from the bunch of informations that we have. We made the analyzation. We reread it. We made some notes, and that notes we need to explain to the audience. So we explain the visualizations to the audience. This is two part. It's like both two-way street, because the data, the visualization can tell us what to learn from the data and to tell the others what is the advantages of our business data or of our system, maybe some service that we have for smart living, etc. Now, for types of visualizations that we have 2D plots. 2D plots are plots that are part of some geolocations. As you can see, here is the Earth map, and we have some geolocation appearing in given points, having some geolocation of x and y as axes or coordinates, geolocation coordinates. On the other side is the temporal. The temporal is 2D plot, but here we have some linear connectivity between the x-axis and y. Mainly temporal are used for some timestamp data when we have starting and ending point, where we have start of the time and end of the time. It's for time series data, so we can know how the data from in the time over the time has some trend. Now, mainly this is used when you have, for example, some product and you need to see where are the peaks. So is it December for Christmas, and is the sales smaller when you have vacations like July? You can take a look of the COVID situation data. When are the peaks? How through the time COVID-19 had increased or decreased number of hospitalized cases, for example. Then on the other side is the multidimensional. It's 3D systems where we need one more dimension to be added to have more robust models, when we need to have models that include one more state to have better visualization of our problems. The hierarchical part is mainly used for seeing the dependencies between the data. So when we have a bunch of different features, when we have more columns appearing and we want to know how these columns are organized, we are making some dendrograms or cluster plots. They are made for knowing uh, how the data is grouping, which two features are closest, how the feature are grouped one by another, does they have any dependencies. We can take a look with the hierarchical. Here we can have a look of how first we have some here branching together. From the colors we can tell that we have blue, green and red, three different clusters, three different groups from the given data set. That's some example. At the end are the networks. In the network part we have some linkage, some relationship between the nodes. It can be social networks, it can be products in different cities, or it can be markets in different cities, or it can be maybe sensors, network of sensors, and the linkage between them is the dependency, the weight. It may be some cosine similarity or some other, the distance, geolocation distance. It can be some other weight that is important to us, maybe the temperature, the temperature change that has, or etc etc. So we're going to take a look and we're going to take a look of all of these graphs and go through different type of libraries in Python. We're going to mainly stay in Python because today Python is open source language. It's a scriptive one. You can access all of the libraries and see their documentation, otherwise see their code if you need to change something, or find quickly with a Google search what you need. Because as I said, Python is today's trend programming language when it comes to data visualization, analytics, or at general data science.